What is an arithmetic series? If I write down what we're adding together, this 2, then 4, then 6, and so on, this series of numbers is an arithmetic series because to figure out the next term at any point, you take the previous term and you always add the same constant to it, which in our case is adding 2. You could always subtract the same constant as well, which is totally valid. But what we've got to figure out now is, how do we figure out the sum of all these numbers between 2 and 100? Well, we're missing a bit of information because first what we got to figure out is in the series 2, 4, 6, all the way to 100, how many terms are there? Because once we figure that out, I will show you the formula to quickly determine the arithmetic sum. So we have another formula here where if I had 2, 4, 6, and so on, if I knew how many terms I had and I wanted to figure out, say, the 100th term, you could simply plug in things here. And so for this formula, a sub 1 is the first term in the series, which is 2, and a sub n would be whatever term we want to figure out if we know we have n number of terms to plug in here, and we know the difference, or d, between the terms is 2 because we're always adding 2. However, the problem here is we're kind of in the reverse direction. We know the last term here, a sub n, is 100, and the first term is 2, but we don't know how many terms we have, n. But luckily, as you can tell with this formula, we have enough information here to figure out what n is. And once we figure out n, we can then gather the arithmetic sum. So plugging in what we do know, this last term here on the left, 100, the first term, which is 2, and the difference between terms, which is 2, the number we're always adding to get the next number, we can actually figure out what n is. So when you expand the right side, this is very simple because 2 minus 2 will cancel out, leaving us with the very easy way to solve for n, which is 50. And that tells us then that in the series 2, 4, 6, all the way to 100, we have 50 terms. And now we have enough information to calculate how many boxes we need. So to figure out a general arithmetic sum where you have n terms, and you know the first term and the last term, it's going to be this formula here. Our final sum is going to be this s sub n on the left. N is 50 from above, and just like above, a sub 1 is going to be your first term, which is 2, and a sub n will be your last term, which is 100. And then when you plug in everything, it works out really nicely, because on the right-hand side, we have 50 times this fraction, which is going to simplify to 102 over 2. And by inspection, we know this is easily going to be computed as 50 times 51, giving you this